everyone, this is Srividya, Assistant Professor in the Department of CSIT. In the last session, we have seen string handling functions and structures in C. In today's session, we will see what are the sorting techniques in C programming language. So, one of the important sorting technique is bubble sort. So, in this session, I am going to discuss what is bubble sort, what is the working principle that exists in this bubble sort, and what are the time complexity of the bubble sort. So, by definition, a bubble sort is a simple comparison-based sorting algorithm. So, it repeatedly steps through the list, compares adjacent items and swap them if they are in the wrong order. Working principle, the algorithm bubbles the largest unsorted element to its correct position in each pass. Suppose there are the list of elements like this. Consider an array. In the array, so this is the array with the index position starts from 0 to 4. So total number of elements in the array is 5. And the list of elements I have taken here is 5, 4, 2, 1, 3. So our aim is to arrange these elements in the sorted order. So we have so many sorting techniques. We can implement any one of the sorting technique to arrange them in ascending order or in the descending order. So how to arrange these elements in sorted order? So first thing, the element that is in the largest unsorted list should be placed in its correct position. So what is the largest element in the array here? The 5 is the largest element in the array, and the second largest element is 4th. So here we have taken an array. Consider the array again. So these are the index positions and this is the array. So what is this bubble sort? So first element in the array is compared with its second element in the array. Obviously 5 is greater than 4. 4 is less than 5. So these two elements get swapped. So after the first 4, 5, 3, 2 and 1. After this, the array is like this. Next, so it will start from where we have stopped. So it reaches to index 1. So now again it will start from index 1. So here again the comparison will start. 5 and 3 gets compared. Obviously 5 is greater than 3. So now these two elements will be swapped. It is 4, 3, 5, 2 and 1. Next, 5 and 2 gets swapped. It's 4, 3, 5, 1. Obviously here 2 is greater than 1. Here 5 and 2 is get compared. So 2 is lesser than 5. So it will swap. 4, 3, 2, 5 and 1. Next. After that 5 and 1 gets compared. Next. It is 4, 3, 2, 1, 5. So this is what we can say when I is equals to 0 or for the first iteration or after the first pass. After the first pass, the first largest element in the array or the largest element in an array. So here the largest element in the array is 5. That is at its correct position. So this is what your first iteration. We are done only with the first iteration. So after the first iteration, you can say the first or the largest element in the array. Out of all these elements, the largest element is 5. So that is at its correct position. So next, second pass or the second iteration. So we have to consider this list of elements. So it is 4, 3, 2, 1 and 5. 4, 3, 2, 1 and 5. 0, 1, 2, 3, 4. So now 4 and 3 gets compared. Again we will start from index 0 only. 4 and 3 gets compared. So the list is 3, 4, 2, 1 and 5. Next, 4 and 2 gets compared. Obviously 2 is smaller than 4. Then we will swap the two elements. It is 3, 2, 4, 1, 5. Next, 4 and 1 gets compared. Now 4 and 1 gets compared. 3, 2, 1, 4 and 5. Next, 4 and 5 again gets compared, but they are at its correct position. So no need of any swapping, but we will write the list. 3, 2, 1, 4 and 5. No swapping was taken place, but we should compare these two elements also. So 4 and 5 gets compared. And this is the second iteration. So after the second iteration, what we can say? The second largest element in the array has its correct position. So what is the second largest element among all these elements? 4 is the second largest element in the array. So that is at its correct position. Next, in the third pass or in the third iteration, so what we are doing, every time we are taking an element in the array and we are comparing that element with the adjacent element in the array. So next, the iteration, it's 3, 2, 1, 4 and 5 in the list. So 3 is compared with 2. 3 is compared with 2. So 3 and 2, obviously 3 is greater than 2. It's 2, 3, 1, 4 and 5. Next, 3 is compared with 1. Obviously 1 is smaller than 3. So now 2, 1, 3, 4 and 5. Next, 3 is compared with 4. No need of any swapping, but the list is 2, 1, 3, 4 and 5. But comparison is done. No swapping is to be made. Next, after this 4 and 5 gets compared. No swapping, but comparison is done. So 2, 1, 3, 4 and 5. So after the third iteration, what we can say? The third largest element in the array. What is the third largest element in the array? It's 3. That is at its correct position. Okay. So this is the third iteration. Next, this one is your first iteration, next second iteration, third iteration and now fourth iteration. So what we can say by this? This is when I is equals to 0, this number of passes or elements to be swapped. Next, when this one we can say when I is equals to 1. Next, this is an I is equals to 2. Now the fourth iteration, when I is equals to 3. So when I is equals to 3, the list of elements are 2, 1, 3, 2, 1, 3, 4 and 5. 0, 1, 2, 3 and 4. Again the index positions are 0, 1, 2, 3, 4 and 5. So now again swapping. Comparison first, 2 is greater than 1. No swap, 2 is greater than 1. Yes. 1 is smaller than 2. So swapping is done. 1, 2, 3, 4 and 5. Next 2 is compared with 3. That is at its correct position. No swapping, but the list is 1, 2, 3, 4 and 5. Again 3 is compared with 4. No swapping because they are at its correct positions. 1, 2, 3, 4 and 5. Next 4 is compared with 5. 4 is compared with 5. So no swapping. The list is 1, 2, 3, 4 and 5. So this is the final sorted array. So what is the final sorted array? After 4 iterations, you can say this is your sorted array. This is your sorted array. So we have taken the list 5, 4, 3, 2, 1 as the array, and after 4 iterations, so when I is equals to 0, this one was taken place. When I is equals to 1, I is equals to 2, I is equals to 3. So by this we can say, if you have n number of elements, like n number of elements in the list, the number of iterations will be n minus 1. So number of iterations will be n minus 1 if there are n number of elements in the list. See here 1, 2, 3, 4, 5. 5. N is here. In this case, it is 5. If there are 5 number of elements in the array, the passes will be, or the iterations will be n minus 1. So total how many passes we made? So it is 1 set 1, 2, 3 and 4. So we got 4 iterations or 4 number of passes. With this 4 number of passes, we have completed this sorting. So 1, 2, 3, 4, 5 is your sorted list. We have done in ascending order. You can also arrange in descending order. So what is the time complexity of this? The best case is order of n when the array is already sorted. Okay, when the array is already sorted, the best case here is order of n. Average and worst case are order of n square due to the nested loops. And space complexity is order of 1 in place of sorting. So the pros are here: simple to understand and implement, works well on small data sets or nearly sorted arrays. So if your array is very small, it's easy to implement bubble sort technique. Insufficient, so what are the cons? Inefficient for large data sets due to its order of n square time complexity. Not suitable for performance critical applications. So let's see with the program. So this is the program. So before starting the program, so based on that, whatever the example we have taken, you can implement the bubble sort technique. You can write your own. Like, so we have declared the array first. So the size of the array, if you want to fix it in compile time, you can take it like this. Okay, or else if you want to enter only 5 number of elements, you can write here a of 5. And to give the size at runtime, we can use the scanf function. Scanf %d comma address of n. Suppose I have taken only 5 number of elements. So in runtime, I can give input as the 5. Okay. So next, how to enter the elements in the array? For I is equals to 0, I less than n, I plus plus, scanf %d comma address of a of I. So with this scanf function, you can give the input in an array. This was already discussed while discussing 1D arrays. Next, so what logic you will write for swapping? Because you have taken the array and you have compared the two elements, like suppose 1 and 2. You have compared whether one is less than or greater than the other adjacent element that is in the array. And what you have done, you have swapped them. Suppose if the second element is largest, you have moved to the last position. And so for that, and I told if you have n number of elements, we have n minus 1 passes. So it is when I is equals to 0, you can say I less than n minus 1 I plus plus. Next, how many loops we need here? We need 2 loops here because one loop is for number of iterations. Why we need 2 loops here? One loop is responsible for the number of iterations. When I is 0, I is 1, I is 2, I is 3, like we have seen in the example. And the other loop is for the comparisons. So we have done the comparison. So we need 2 loops here. For j is equals to 1, j less than n minus 1, j plus plus. J less than n minus 1, j plus plus. See, in the previous 2 cases, in the second iteration or in the third iteration, even though the array was already sorted, like 3 and 4, 5, they are already in the sorted order. No need to again check whether they are sorted also. So to reduce this, we can use here, you can just modify this loop. J less than n minus 1 minus I. To reduce this number of comparisons, you can write this j less than n minus 1 minus I. And if a of j, what we have done? So one loop is for number of iterations, and for comparison we need another loop, that is j. If a of j greater than a of j plus 1, so we'll take a temporary variable. T is equals to a of I, a of j is equals to a of j plus 1, and a of j plus 1 is equals to t. So this is what we will do in just general swapping. So here the same was written. For I is equals to n minus I less than n minus 1, and j is equals to 0, j less than n minus 1 minus I, j plus plus. Suppose see, for I is equals to 0, I less than n minus 1, I plus plus. So we have 5 number of elements, let's suppose. So it is 5 minus 1. So I is 0, 0 less than 4, condition true. Now control will enter inside the inner for loop. For j is equals to 0, j less than n minus 1 minus I, j plus plus. So it's 0, 0 less than n value 5 minus 1 minus 0. So 0 less than 4, j plus plus. 0 less than 4, condition true. So what is the logic here? If a of j is 0, a of 0 greater than a of 0 plus 1. A of 0 is what? A of 0 is 4. 4 greater than a of 0 plus 1. 0 plus 1 is 3. 4 greater than 3. Condition true. So now again control will enter inside. T is equals to a of 0. That is 4. Because a of 0 is 4. Next, a of j 0 is equals to a of 0 plus 1. That is 1. A of 1 is 3. A of 1 is 3. Okay. Next, a of 0 plus 1, that is 1, is equals to t. That implies it is 4. So now a of 1 is equals to 4. So what we have replaced? So it is asking you to replace the a of 0 value with the 3 and a of 1 value with 4. So now swapping is done for the first pass. Okay. So here the swapping was done. So after like this, the loop will repeat. Again j will be incremented. J will be 1. 1 less than 5 minus 1 minus 0, that is 4. 1 less than 4, again condition is true. 1 less than 4, condition true. Again here a of 0. A of 0 is what now? 3. J value. J value is now 1. A of j greater than a of j plus 1. A of j is a of 1 greater than a of j plus 1. It is 2. So what is a of 1? A of 1 is now 4. 4 greater than 1, condition true. 4 greater than 1, condition true. Again same logic. T is equals to a of j, that is 1. So now 4 and 1 gets swapped. So this value will be replaced here and this one will go here. It is 3, 1, 4, 2 and 5. So after that the sorted array here is, we got the answer here. It's 1, 2, 3, 4 and 5. The final sorted array. So to print the final sorted array, again we need to write a for loop. For I is equals to 0, I less than n, I plus plus, printf %d comma a of I. So with this you will get the sorted element values. So this is your logic for the program. So just we will compare the adjacent elements in the array and we will do swapping. This is bubble sort. In the next session I am going to talk about insertion sort in C.